It worked. 86 and 94 make 180. Alright, on to the last several questions here. It says find x such that we are perpendicular. Again, perpendicular means 90 degrees. So I need to make this picture such that this line and this line make a right angle. So if I'm going to do that, that means I need this to be equal to 90. I need this degree to be equal to 90 degrees, and that would make these perpendicular. So solve that quickly, add the 2 over, divide the 4. You got y. Cool. Now we got to solve for x. And again, if these truly are perpendicular, you got a 90-degree angle here, but you also have a 90-degree angle here. Which means if I combine these two angles, I should get 90 degrees. So let's do that. Combine. We'll do that here. We got 2x plus 5x plus 6 equals 90. Ran out of room a little bit there. That's okay. This is 7x. Take the 6 over. So subtract and divide. And you get 12 for that. So we have it. So to make these perpendicular, 90 was the key. We had to make this equal to 90, and we had to make these two combine to 90. Example 6, find the value of the variables. So in this scenario, here's what we got. We've got that this line intersects this line. And now because of that, we've got these two angles, which are vertical angles. And we learned that vertical angles will always be the same. So that means that 2x plus 25 is equal to 3x minus 10. So now do your algebra. Take this 2x and subtract it. Take this 10 and add it. And we've solved for our x. Now we have to solve for our y. And I'm going to go ahead and check my answer before I do that. So that's 3 times 35 minus 10. That's 95. Check your answer here. That also is 95. Which means, if this is 95 and that's 95, we need to have 180 degrees here. So this has to be 85. Because what's 95 plus 85? 180 degrees. And this one is also 85. And check this out. If we take 95 plus 85 plus 95 plus 85, what are we going to get if we go all the way around? 360. That's how it should work. We get 360 degrees total. Number 7. Example 7. This time we do not get the picture. We have to draw our own picture. They say that ray BA and ray BC are perpendicular, so you have to draw that picture. So pause the video and try to draw that picture. There's ray BA. There's ray BC. And we will make them perpendicular. Next, D lies on the interior of ABC, so we can put a D in there, and we got a new ray. Now, does it say that this bisected? Can we assume that this is 45 degrees and this is 45 degrees because 45 plus 45 is 90? We cannot make that assumption. But what we do know is that ABC is 5r plus 20. That's 5r plus 20. And DBC is 5r minus 27. We can use this information to solve for this angle right here. And how are we going to do that? Here's what I know. If I start with 90 and I subtract this angle, I'm making that way more complicated. Let's stop that. Pause. We know that this opening is 90 degrees. So 5r plus 20 is equal to 90. Subtract that over, and now divide. You get 14. So r is 14. Once we have that r is 14, you can go back and plug that in and figure those out. Okay. I think that, no. Let's see how much time we got left. I've got enough time. In this picture, there's quite a few equations. Yeah, I'm just going to do it. Alright, let's do it. So, in this picture, there's some vertical angles that I could use to solve for x and y. I'm going to go ahead and do that. So, one equation that we have is that 16y minus 2x is equal to 12y plus 30. That's one equation. The other equation we could use is that 2x plus 2y is equal to 4x plus 10. We got two equations, and we've got two unknowns in x and y. This is called a system of equations. So what I need to do is clean this up. I'm going to bring this up here and clean it up. So the top equation we can clean up to negative 2x. I'm going to bring the 12y over with the 16, so that's 16 minus 12y. That would be 4y is equal to 30. For the bottom equation, I'm going to make it look like that. I'm going to put my x's first, so bring this 4x over. The 2y is there, and then we've got 10. This is called a system of equations. When you have a system of equations, you want to line the variables up. You might remember this. This is called elimination. I know you learned this in algebra, but we'll review it. And what I can do is I can add these two together. Sorry, subtract. I want to subtract, because negative 2 minus negative 2 is 0. Let's eliminate. What is 4 minus 2? 2. What is 30 minus 10? So we just solved for y. We were able to eliminate the x, and then that allowed us to solve for y. And now you got to go and figure out what x is. So what you have to do is take this y and plug it back in, say here. So 2x plus 2, so we're going to take that y and turn it into a 10. Like that. And now do your algebra from there. So take this 2x and subtract it. That's 20. Take this 10 and subtract it. Take that 2 and divide it. There's the answer to your system of equations using elimination. Remember that from algebra? Whew, it's been a long time. Over here in example 9, we've got these two angles are the same because they're vertical. So therefore, I can do x squared plus 5x is equal to 4x plus 6. That's a good equation. This has an x squared. I'm not sure that we've done one like this yet. When it has an x squared, that's called a quadratic. And so the first thing to solve a quadratic is you got to make it look like that. You probably remember this from algebra class. You got your A, B, and your C, and then there was a equation. B plus or minus square root of u minus 4ac over 2a. And you could use that equation to solve something like this. But it's not always going to work. Well, this will always work. There's a shortcut, and the shortcut was this. You make your equation look like this, so you got to bring this over, you got to bring that 6 over, and then you try to, it's called factoring, and you got to think of two numbers that add, in this case to 1, and multiply to negative 6. And that was plus 3 and minus 2. What is 3 minus 2? 1. What is 3 times negative 2? Negative 6. And then you solve the equation from there, so x equals negative 3, because negative 3 plus 3 is 0, or x equals 2, because 2 minus 2 is 0. So these are your answers to that equation. In geometry, you have to check your negatives. If I plug in negative 3, that would make this negative 6. There's no such thing as a negative angle, so actually that doesn't work. It works in algebra, but not in geometry. If I plug in a 2, what do I get? That's 8 plus 6. 8 plus 6 is 14. And if I plugged in a 2 for this one, I get 4 plus 10, which is 14. That's what we wanted. We wanted these to be the same. Alright, so if I just messed you up, just rewind until we stop at example 7. 8 was called a system of equations. It's a good algebra. 9 is called a quadratic. It's good algebra. You should have learned that in algebra. But this is geometry. Those do show up, and eventually we will test on these things. But for now, let's just focus on the geometry. And that's that.